Okay, so we want to look at the second derivative test and look at your two graphs here. This is a maximum, right? Local max. I don't know what else is happening here. It's absolute in terms of my picture. What's true with the second derivative here at this, what I would call C? F double prime of C, is it concave up or concave down there? Concave down. So that's less than 0. What about at my minimum? There's my C value. There's my minimum. It says concave up or concave down? Concave up like a cup, right? So what's true with the second derivative? It's positive. Well, that's the second derivative test. What you do is you find the second derivative, evaluate the second derivative at your critical point, and if it's negative, then you found a maximum. It's counterintuitive. I want to say it's the other way around, but it isn't. If the second derivative is positive, then I draw the picture to be concave up, and I have a minimum. So there's the language for the second derivative test. The test requires us to know the second derivative only at the C value. I don't have to look at what's happening on each side. And sometimes, especially in BC Calc, we only have the second derivative to look at. We don't have the function, so we can't use the first derivative test. Remember what the first derivative test is? Did you guys do your homework? F prime. Here's C. If this is positive and this is not negative. Mine's probably not simplified. I don't know.
It was like -3 to positive.
Sometimes the book's wrong, sometimes I'm wrong.
For the 1 and 2, is one of them supposed to be minimum? They both be maximum.
Yes. Okay, now I don't remember which is which because I haven't memorized it. But if the second derivative is negative, it's concave down, so this is a max. If the second derivative is positive, and fix your sheet because I did type it wrong, this would be a minimum. So I'll memorize it, I just draw my pictures. Sasha? Yes. Your second derivative could be 0 or undefined at that point. Think of the absolute value function. At that corner point, which is a minimum, it is the first derivative and second derivative are undefined. So if my function goes from positive to negative, my derivative, excuse me, I said that wrong. If the derivative goes from positive to negative, it means it's increasing and decreasing, then this is a, not necessarily, I didn't say anything. It's a max. Now, if I have C value and it's undefined and it's positive to negative, I assure you it's going to be a sharp corner. It's undefined there, that means it's going to have to do something like this. But if it's 0, if this is 0, it's always going to be nice and smooth. I don't need the second derivative.
So if it's undefined,
The second derivative is still undefined there. You take your critical point, like an absolute value of x for x equals 0. Second derivative is undefined. Yeah, sometimes the second derivative test will fail. In that case, it fails. Because I can't find the second derivative on that one. Well, let's try a problem. We're going to be out of time, but let's look at this. Let's go for the second derivative test. There's the first derivative. Let's find the critical points. Remember, this is the derivative. So when you take your test and your quizzes, make sure you read the problems carefully, that you realize that's a derivative, not the function. Easy to not read correctly. So this is clearly okay everywhere. There's no places where it's undefined. Let's find out where the zeros are. What can I factor out of these two? More. 4x squared. And I'm left with x minus 3. So I want to find my critical points. We'll do it one way. X equals 0 and x equals 3. So there's 0, there's 3. And you probably prefer to test regions. Is this x squared going to change the sign at all? No. You remember it's a bounce. But if you don't want to think that hard, let's put in 10. This is positive. I'm going to label these. These are zeros. What's an easy number between 0 and 3? 1. That's negative. That's positive, so this is negative. And if I try negative 100, this is still positive, but this is negative, and that's negative. So what happens? Do I have any max or mins?
Yeah,
There's a critical point or extreme value at 3. Which one is it? Max or min? Yep, I'm decreasing, increasing, so it's a minimum. Let's find f double prime of x. Now do the original one, don't do the one I don't want to use the multiplication rule. So what's that equal to? Derivative of 4x cubed is 12x squared minus 24x. Now I will evaluate f double prime of 3 there, and all I have to know is positive or negative. So it's 12 times 3 squared is 9, minus 24 times 3. What's 12 times 9? Does anybody know? 108. 24 times 3? No. 24 times 3. 72. So it's positive or negative? Oh, I thought he said 32. I just didn't hear you right. He's got his hand in front of his mouth, I say. Is that positive or negative? It's what? Positive. Okay, that means my function is concave. Up or down? Up. So I have a minimum. Now, when I did the homework problems, I tried to do both tests as long as the second derivative was reasonable to find. Most of the time, you're going to use the first derivative. And I can sketch my graph like right now based on that. I don't even need to look at the second derivative.
So both those tests found the same thing.
They both did the same thing. But they can force you to use the second derivative test on the exam.
How did it, okay, you use this because they saw it.
This is my critical point. Those are the C values. And I just evaluate it in the second derivative. That's all there is.
But you have to constantly stay with that.
You do. Right. Sometimes it's easier. Usually you'll just use the first derivative test. You don't have to do the second, but sometimes it's easy to do the second. Yes.
So you don't have to do both of them?
No. I did both of my answer sheets so that you could see both. Wait, what's this look like? My function's decreasing, and increasing. That's what it looks like. Remember, if it's 0, it's smooth. And you don't have to worry about sharp corners. You don't have to worry about concavity. It has to change concavity.
With the second method, would you use 0 as well?
No, well, I could have tested it, yes. And what's f double prime of 0? That's 0, so I know nothing.
But should you tell? Oh, I know.
Yeah, if I don't do a first derivative test, yes, I probably should. Good point. You had fun with this iPad?
I loved it.
Yes,
I have my desk every day.
we'll be doing it more.